Let's look at another equation with the same base. Let's consider our e, the natural logarithm. E to the 1 minus 2x equals to e to the 3x minus 5. Since the bases are equal and the numbers are equal, then this simply means that the exponents should be equal. So instead of caring about the bases, I focus on the exponents. 1 minus 2x should be equal to 3x minus 5. Now this is a linear equation. I need to separate the unknowns from the constants. These are the unknowns, these are the variables, these are the constants. So I will move the unknowns on the left side of the equation, minus 2x minus 3x, because when I move this on this side, it changes the sign of that. And I will move the 1 on this side of the equation. So I have negative 5 minus 1. And I have a very simple linear equation to solve. Negative 5x equals to negative 6. I solve for x, and this gives me x equals to negative 6 over negative 5. I can simplify that to 6 over 5. And this is my final answer. So this means that if I replace the x right here on the initial equation with 6 over 5, then the exponents will be equal. So that's one of the examples that we want to see. Let's look at a different example. 5, 2x minus 1 is the exponent, equals to 1 over 125. Okay, again, when we have only one power and the other is a constant, like 1 over 125, what we need to do is to try to rewrite the number as a power of 5. Well, the first thing that I can see right here is that 125 is 5 to the third. So if I want to do this separately down here, just to make sure that I don't make any mistakes, then I can rewrite this as 1 over 5 to the third. Now I know that if I have a power at the denominator and at the numerator I have the number 1, then I can move the power at the numerator and I can have this power back with a negative exponent. So basically 1 over 125 is equal to 5 to the negative 3. So I can rewrite this as 5 to the negative 3. Why did I do this? Well, because basically I wanted to rewrite the second side, the right side of my equation, 125 here, as a power of 5. Now my bases are the same, so I can focus on the exponent. And I have 2x minus 1 equals to negative 3. And this tells me that 2x is equal to negative 3 plus 1. And this means that 2x is equal to negative 2. So x is equal to negative 1. How do I do that? Okay, I divide both sides by 2. And I simplify right here the 2 with the 2. And what I have is x equals to negative 1. And that's my solution. Should we do one more problem? Okay, let's do one more problem. And I'm going to work the following problem for you. So as you can see, every time that you work with exponential equations, you need to see what is more convenient for you to do. Like, for example, how am I going to get rid of my exponent? What should I do in order to make the two powers to have the same base? So let's work on the following problem. 7 to the 3x minus 5 equals to 49 to the 2x plus 1. Again, the problem right here is that I do have two powers, but the powers are different. The beauty of that is that the 49 has some relation with 7. What is the relation of 49 with 7? Well, it's 7 squared. So instead of having 49 on the right side of my equation, I can replace that with 7 squared. When I replace though, since this is the exponent of 49, I need to make sure that I put it in parentheses to remember that 49 has been replaced by 7 squared, and 2x plus 1 is the exponent of the 49 here. So this now will give me 7, 3x minus 5 is the exponent, and on the other side I can apply the rule of exponent that tells me that a power to a power is equal to the base to the product of the powers. So this is 7 to the 2 times, keep the parentheses in order to avoid any mistakes, and you can take one more step at your exponents to simplify the exponent of the right side to become 7 4x plus 2. Now, the bases are equal, so I can focus on the exponents again. And this will tell me that the exponent of the right power, of the left power, will be equal to the exponent of the right power. This will give me a linear equation that I need to solve. 3x minus 4x is equal to 2 plus 5. And this tells me that I have 3x minus 4x is negative x equals to 7. I reverse the signs here in order to find what is the x equals to. So I multiply basically by negative 1 both sides of the equation, and I have x equals to negative 7. And that will be my answer for this problem. So right here we solved two different problems, problem 1 and problem 2.